Alright, hey guys, today we're going to talk about the first part of Unit 5, or Chapter 6, which is the inverse sine, cosine, and tangent functions. So, this is really just a combination of two things that we've kind of talked about a lot already, and that's trig functions and inverse functions. So we're kind of combining those two together. So first we're going to start talking about inverse sine function. Now, the key thing with inverse functions is we flip the x and y, and that it has to pass, in order for the inverse to be a function, it has to pass the horizontal line test. So if you remember just regular old sine of x, which looks like this, the domain is from negative infinity to positive infinity, and the range is from -1 to 1. Now, if we were to look at that graph, though, that would not pass the horizontal line test, because we'd run into a problem here and here, or many places, okay? So what we're going to do is we're going to restrict that sine function to where the inverse does exist. Okay, so we're just going to take, think about it as taking a little piece of that sine graph. So from -π/2 to π/2. And therefore, it would pass both the vertical line test and the horizontal line test. So you can see all that happened here was I took that little piece and copied it down there. And so my blue piece right here, they made it pink over here, so π/2, 1, and -π/2, -1. So in order to get my inverse function, I'm going to flip my x and y. So π/2, 1 becomes 1 π/2, and then -π/2, -1 becomes -1 π/2. Okay, so the domain and range will just flip. So the domain comes from the old range, so it's going to be from -1 to 1, and I'm going to write that in interval notation. Now for the range, well, we would say it's negative infinity to positive infinity, but remember we restricted that because we want it to be a function. So we're going to write that as -π/2 to π/2, including both of those endpoints. And we'll talk about an example. This is kind of the big picture, and then we'll talk about how we actually use that. So the exact value of sine inverse of 1. So this is what this is saying. Where does sine of x equal 1 within my restrictions? So within -π/2 to π/2. And we're assuming that those are my restrictions unless they tell me otherwise. So unless they give you another set of restrictions, sometimes we like to do 0 to 2 pi, but otherwise we're assuming these are our restrictions. So where does sine of x equal 1? In my little blue piece right here, we can just look at the graph, and that's going to be up at π/2. So that's your answer. All right, this one asks, where does sine of x equal -1/2? All right, so first of all, I'm going to kind of sketch out a little mini unit circle here. So -π/2 to π/2. That's going to be the right side of my unit circle. Okay. So sine of x equals -1/2. So sine is negative, so it's got to be down at the bottom. And that's going to be right here on your unit circle. Now, what angle is that in radians? That is 11 π/6. Now, here's where it gets a little bit tricky. We can't write that as 11 π/6 because our interval is -π/2 to π/2. Okay, so we're going to have to write that as a negative angle coming from 0. Okay, so how much did I go down from 0? Okay, well, this is also 2 pi, right? Or 12/6. So I went down 1/6. So that's also -π/6. It's a coterminal angle. But we have to write it like that because we're referring to this as -π/2 and π/2. Okay, and 11 π/6 would technically be another time around your circle. Okay, all right, so using your calculator, if your point is not on your unit circle, like 1/3 and -1/4, you'll have to use your calculator. Now we know our restrictions are between -π/2 and π/2, so your calculator should be in radian mode. So pause the video for a second and try both of those. All right, so you should get for the first one, for sine inverse of 1/3 to 3 decimal places, 0.34. And then for the second one, -0.253. okay? And again, it's not going to be an exact value, so that's why you need a calculator. All right, next. So next we're going to talk about if we compose a couple of functions. So here we have something where we have sine of x and we have sine inverse of x on the inside. So let's start if we have sine of x on the inside. So if we have sine of x on the inside, if that sine of x is within my restrictions, so let's say it's pi over, or let's just say it's 0. That's an easy one, okay? Because I know that's within my restrictions, because I know it has to be on the right-hand side. All right, so what is sine of x? Sine of x is 0 at that point. So then I'm asking myself, sine inverse of 0. So where does sine equal 0? Well, that's back at this point. So I get back my 0 or 2 pi. And in this case, it'd be 0 because that's what's within your restrictions. Okay? So essentially, you get back the same angle that you started with because you're within these restrictions. Okay? Same thing if you start with the inverse and you start with an output that is between -1 and 1. Okay, so we could do an example. Let's see. So sine inverse of 1. So where does sine equal 1? That's where does my y value equal 1? Well, that would be up at pi over 2. All right, what is the sine of pi over 2? Well, the sine of pi over 2 is 1. And you notice I get back what I started. So if the original, if I just have sine of x, and that's in between my restrictions, then I'm just going to get back what I started. And if not, we'll talk about what happens in a second. And then if the inverse, because remember you're switching your x and y, is between -1 and 1, then you're going to get back what you started as well. Okay, and it gives you some examples there. Let's talk about this down here, sine inverse of 1.8. If you were to type that in your calculator, you get an error. Why is that? Because sine only goes between -1 and +1. It will never equal 1.8. It's never going to be lower than -1, never going to be higher than +1. All right, so sine of 3 pi over 4. All right, so here we know these are our restrictions. 3 pi over 4. Now, this is where we have a little bit of an issue. This is what I was talking about a second ago, is because 3 pi over 4 is not in my restriction. So I can't just kind of cheat and take the easy way out and say the answer is 3 pi over 4 because it's not within my interval, okay? So I actually have to do a little bit of algebra here. So what is the sine of 3 pi over 4? Well, that's square root of 2 over 2. So then I say, well, where can I find the sine value of square root of 2 over 2 within my interval? And that's going to be at pi over 4. Okay. All right, next one, sine inverse of 0.45. Now notice this is an inverse, so I'm looking for that to be between -1 and +1. Is that between -1 and +1? Yes, it is. So then I'm just going to get back what I started, which is 0.45. And that one you wouldn't be able to do without a calculator because it's not on your unit circle if it wasn't within your restrictions. Okay? All right, next we have inverse cosine. Very similar concept, but our restrictions are going to be a little bit different. If you notice, if you went from -pi/2 to pi/2, that would not pass the horizontal line test because it would run in two different places. So our restrictions for cosine are going to be from 0 to pi, okay? Because that's going to create a line that will not intersect a horizontal line in two different places, okay? So exact same concept here, except now our restrictions are from 0 to pi, including both 0 and pi. So the domain is still -1 to 1, because that was your old range. And the range is now 0 to pi, okay? All right, so find the exact value, cosine inverse of 0. So we're saying, where does cosine equal 0 within my interval, okay? Or within the blue section here. That's going to be, where does it intersect the x-axis? And that's at pi over 2. Okay. Next one, where does cosine equal negative square root of 2? Now here, if we drew out our restrictions, it would be the top part. So between 0, remember this is 0 and this is pi. So where does it equal negative square root 2 over 2? So that's going to be right over here. Okay, and therefore that is at 3 pi over 4. All right, exact same concept as what we just talked about with sine. So, but here we're looking for it to be between 0 and pi if we have cosine on the inside. And if we have cosine inverse on the inside, then it has to be between 0 and 1 because we're talking, sorry, negative 1 and 1 because we're talking about my output here, okay? Or my original output, which corresponds to my range, okay? So cosine of pi over 12. So first we have to answer the question, is that between 0 and pi? And the answer is yes. So therefore, I'm just going to get back what I started, which is pi over 12. And for right now, you would need a calculator. We're going to talk about later how you can actually find that one without a calculator. But for now, you would need a calculator to do something like that if it wasn't in the interval from 0 to pi. All right, next we have negative 0.4, but this is an inverse right here. So is that between negative 1 and 1? Whoops, the answer to that is yes. So I just get back negative 0.4. Okay. All right, the last one we're going to do is inverse tangent. So tangent is a little bit different, but it should be pretty easy to visualize. So the part that's invertible is going to be just one little section of the function. Okay, so it's going to be actually the same numbers or the same values as sine, so negative pi over 2 to pi over 2, but we're not going to be able to include those endpoints because those are asymptotes. So it's not going to exist at negative pi over 2, and it's not going to exist at pi over 2. So the domain is the old range. Okay, so the old range was negative infinity to positive infinity, so that's going to be my new domain. Okay, and then the new range is negative pi over 2 to pi over 2. Okay, and notice this is the exact same values as sine, but sine we include the endpoints, tangent we don't because there's asymptotes. All right, so where does tangent equal 1? So I'm going to go ahead and sketch this out. So tangent is sine over cosine. So in order for when I divide a number for it to equal 1, it's got to have the same value. Okay, so where it has the same value is right here. And that is at pi over 4 because they both equal square root of 2 over 2. All right, and last one right here is find the exact value of tangent inverse of negative square root of 3. So again, I'm going to sketch this out here. So I know it's negative, so I've got to be in the fourth quadrant because that's where one guy is negative and one guy is positive. So, and I know I'm going to be dealing with either in degrees, it would be 300 or 330. Yeah, wait, that's right. 270, 300, 315, 330, 360. Yep. Because the one in the middle, which is 315 degrees, is my square root of 2 over 2. Okay, and that goes back to unit circle. So I have square root of 3 over 2 because that's your long triangle. Negative 1/2 because you went down, and then 1/2 negative square root of 3 over 2. All right, so I just kind of pick one. I don't really memorize what's tangent. I just kind of pick one, and if I know it's not that one, then it's the other one. But you shouldn't have to go through all 4 of them. I narrowed it down to 2 of them because I'm within my restrictions, and I know tangent's negative, so I have to be in the fourth quadrant. So you should only have to divide one of them, or 2 of them, I guess, if you're unlucky. All right, so sine divided by cosine is tangent. So I have negative square root of 3 over 2, because that's my sine, times 2 over 1. Keep, change, flip. So cross out my 2, and I get negative square root of 3. So that's the right one that I want, is this guy right here. So now I just have to figure out how to name that angle within my restrictions. So that's going to be, this we said before was negative 1/6. So this right here would be negative 2/6. I can simplify that to negative 1/3. So that's going to be negative pi over 3. Remember, whenever you're naming within your restrictions are negative, so you need to name those angles as negative angles. Okay? And that gives you a summary of inverse sine, cosine, and tangent.